This is video number 6 in the atomic structure topic. It's GCSE dual award chemistry. Obviously, this is also part of the triple award. As always, I'm going to recommend that you pause the video as you go, try out the activities, and then you get a chance to review them. So in this one, we are going to look at the relative charge, mass and location of each of the subatomic particles. We need to know what the atomic number and mass number tell us about an atom, explain why atoms have no overall charge, and know that atoms of a particular element have the same number of protons. And we're going to start off with this table, something that you will be expected to fill in from scratch. So if we take a look through the relative charges, remember we use relative charges because we don't want to use the real numbers. They're far too small, far too fiddly. We have got to remember that protons are positive, electrons are negative, and the relative charges are +1 and -1. Neutrons are neutral. They have a charge of 0. So proton positive, neutron neutral, electron, the other one, negative. Now, from there, we have got the relative masses, and the protons and the neutrons are equal in mass. They have a relative mass of 1, and we've got to remember the electron is much, much smaller. So in this case, you can say almost 0 or negligible. If you want to be really specific, it's around 2,000 times smaller than a proton or neutron. If you want to be more specific, it's around 1,840 times smaller. Okay, have a go at this. And the numbers that you have here, you'll notice, are in a different position to where they are on your periodic table. What does the atomic number tell us about an atom? Well, atomic number is the number of protons. The mass number is the number of protons and neutrons combined. And that leads us to a calculation that you will need to be able to do. Neutrons, if I want to work out how many neutrons lithium has, for example, I take the mass number of 7, I subtract the atomic number of 3, and that tells me that lithium has got 4 neutrons. Look carefully at the table above. What can we assume about the numbers of protons and electrons if all atoms have an overall charge of 0? Now, the table that we looked at on the previous page, we know that protons have a charge of +1. We know that electrons have a charge of -1. So to get to an overall charge of 0, there must be an equal number of protons and electrons in any atom. And you can see that there, taken from the table. We know they must be equal in number. This is a good opportunity to just start using the periodic table, see what you can do. So I go straight through. I find the symbols fairly straightforward. They're all on the periodic table. They'll all be provided. The atomic number is, you can see them here, 1 for hydrogen, 5 for boron, 7 for nitrogen, 12, 15, 20 for the remaining 3. I'm going to jump across to number of protons now. A number of protons, you will notice that this is identical. The number of protons is equal to the atomic number. And now let's also do the number of electrons. This third column that remains identical, because in an atom, the number of protons is equal to the number of electrons, and the number of protons is equal to the atomic number. I can then go back to the periodic table to find my mass numbers. I've got 1, 11, 14, 24, 31, 40, taken straight from the data provided, and then I need to work out the number of neutrons. I've done hydrogen first because there's something really quite unusual about it. It's the one example of an element that contains no neutrons. For the rest of them, I'm simply going to take my mass number and subtract my atomic number. And I end up with the numbers that we have here: 6, 7, 12, 16, and 20. So you must remember which is the atomic number and which is the mass number. There is an easy way to remember it, and that is that the mass number is the larger of the two numbers. The one exception to that rule is hydrogen, where the atomic number and the mass number are equal, hence no neutrons. That takes us to the end of this video. Thank you for listening, and goodbye.